12th subject physics, 3rd chapter, kinetic theory of gases and radiation. Kinetic theory of gases and radiation. From the chapter, let us see some of the formulae. First is Boyle's law, which is given as phi is inversely proportional to P at constant T. That is, volume of given mass of gas is inversely proportional to its pressure at constant temperature. Second law, that is Charles' law. Charles' law, phi directly proportional to T at constant P, that is volume of given mass of gas is directly proportional to its temperature at constant pressure. Third is Gay-Lussac's law. Gay-Lussac's law, that is P is directly proportional to T at constant phi, that is pressure of given mass of gas is directly proportional to its temperature at constant volume. Fourth formula is for ideal gas equation. For ideal gas equation, that is for 1 mole of gas PV equal to RT, PV equal to RT, or for n mole of gas PV equal to nRT, PV equal to nRT. Fifth formula for number of moles. Number of moles n equal to mass of gas m, mass of gas m divided by molar mass m0, molar mass m0. That will be written as n upon Na, n upon Na, that is number of molecules upon Avogadro's number, number of molecules divided by Avogadro's number. Sixth formula is again for PV, PV equal to n kBt, PV equal to n kBt in terms of Boltzmann constant Kb, that will be equal to, that is R is equal to Na into Kb, R equal to Na into Kb. Then seventh formula is for mean free path. Mean free path, lambda is equal to 1 upon square root of 2 pi d square rho, 1 upon square root of 2 pi d square rho, where d square, that is the square of diameter, and rho is the density. That will be written as 1 upon square root of 2 pi d square into n by phi, 1 upon 2 pi d square into n by phi. Eighth formula gives pressure exerted by the ideal gas, that is pressure of ideal gas P equal to 1 by 3 n upon phi into m phi square bar, 1 by 3 n upon phi m phi square bar, that will be equal to 1 by 3 m upon phi phi square bar, 1 by 3 m upon phi square bar, that is equal to 1 by 3 rho into phi square bar, 1 by 3 rho into phi square bar. Then ninth formula is for root mean square, that is Rms speed. Rms speed, it is given as phi Rms equal to square root of 3RT upon m0, square root of 3RT upon m0, where m0 equal to Na into m, where m0 equal to Na into m. Then 10th formula is for average energy per molecule, average energy per molecule, which is given as E by N equal to 3 by 2 kBt, 3 by 2 kBt. Then 11th formula gives Mayer's relation, which gives the relation between specific heat at constant pressure and specific heat at constant volume, that is Cp minus Cv equal to R, Cp minus Cv equal to R. Then it is also given by the formula Cp minus Cv equal to R by J, Cp minus Cv equal to R by J, because that energy will be measured in terms of calorie as well as joule. Then Next formula 12th, that is for monoatomic gases. For monoatomic gases, gamma, that is Cp by Cv. Gamma, that is Cp by Cv equal to 5 by 3 for monoatomic gases. Then for diatomic gases, if these diatomic gases are considered as rigid rotator, then gamma is equal to, that is Cp by Cv equal to 7 by 5, and for non-rigid rotator, gamma equal to 9 by 7, that is Cp by Cv equal to 9 by 7. Then 14th formula gives gamma for polyatomic gases. So in case of polyatomic gases, gamma equal to 4 plus F upon 3 plus F. 4 plus F upon 3 plus F. Then 15th formula gives for thermal radiation, sum of coefficient of absorption, coefficient of reflection and coefficient of transmission is equal to 1. That is A plus R plus T equal to 1, where A is equal to QA upon Q, R is equal to QR upon Q, and T is equal to QT upon Q, where QA is amount of energy absorbed, QR is amount of energy reflected, and QT is amount of energy transmitted, where Q is total amount of energy. Then 16th formula is for emissive power. Emissive power of any body, R is equal to Q upon AT. R is equal to Q upon AT. Q will represent energy, then A is area of that body, and T is the time. Then 17th formula gives coefficient of emission of a body. E is equal to, it is the ratio of emissive power of a body to the emissive power of a perfectly black body. Emissive power of a body divided by emissive power of a perfectly black body, that is equal to R by R0. Then 18th formula gives Kirchhoff's law of radiation, which is the coefficient of absorption is equal to coefficient of emission or emissivity, that is A equal to E. Then 19th formula gives Wien's displacement law. So maximum wavelength, that is lambda max, is inversely proportional to absolute temperature T. Lambda max is inversely proportional to T, or it is given as lambda max into T equal to constant B. Lambda max into T equal to constant B. And 20th formula gives Stefan-Boltzmann law of radiation. That is emissive power R is equal to sigma into T raised to 4. R is equal to sigma into T raised to 4, where sigma is Stefan's constant. So R will be equal to sigma into T raised to 4. That is, this emissive power will be directly proportional to 4th power of absolute temperature of that body, and therefore R is equal to sigma into T raised to 4. So these are some of the formulae from this 3rd chapter, Kinetic Theory of Gases and Radiation.